Hello, it's Michael. In this video, we're going to work on the key thing you need to know to solve word problems and proofs. And that thing is grammar. You need to know grammar. I'm constantly using this to explain proofs and word problems to people, to analyze it for them so they know what to do and what it means. Let's look at a few examples. The two digits in the numerator of a fraction are reversed in its denominator. If 1 is subtracted from both the numerator and denominator, the value of the resulting fraction is 1/2. The fraction whose numerator is the difference and whose denominator is the sum of the units and tens digits equals 2/3. Find the original fraction. Yeah, that blue sentence is kind of hard to understand. The first one you can get, you can stop the video and read it if you want. The second, okay, but the third's usually a little complex for people and we got to break it down so they get it. The fraction whose numerator is the difference and whose denominator is the sum of the units and tens digits equals 2/3. There's just some subordinate clauses that you got to understand there. Example number 2. A man is 3 times as old as the son was at the time when the father was twice as old as the son will be 2 years from now. Find the age of each. It's pretty complex. Example 3. And this is one we'll break down. So this is, instead of a word problem like those two, this is something you'd be asked to prove. If from any point in the base of an isosceles triangle parallels to the equal sides are drawn, a parallelogram is formed whose perimeter is equal to the sum of the equal sides. You might be thinking, huh? You can stop the video and look at it and read it if you want. But like I say, we'll break this down so you understand what it means. We won't prove it, but the point here is just to see how to use grammar to analyze things. So, let's do a little review before we get into the analysis. Remember, a preposition is a word that connects a noun to the rest of the sentence. Here are some examples of, before, under, over, and all that. In Rex Barks by Phyllis Davenport, that's a book about sentence diagramming. She likes to say that prepositions tell you whatever a squirrel could do to a tree. Like it could be in the tree, near the tree, above the tree. So the words before the tree are the preposition. Above the tree, in the tree. Okay, so that's her little trick for helping some people understand it. Now, a prepositional phrase is a phrase made of a preposition. Prepositional phrase having to do with the preposition. So in the phrase, you've got the preposition, the noun that goes with it, also called the object of the preposition, and then adjectives modifying that noun. So here are some examples. Here are 5. In the tree, above the oak tree, in Jack's statue's base, under the big granite rock, near a triangle. So all those are prepositional phrases. You've got the preposition, in, above, in, under, near. You've got the noun, tree, base, rock, triangle. And those nouns are all the objects of the prepositions. We're going to have to be looking for these things and eliminating them from a sentence to see what's left. Now, in contrast to a phrase, a clause is a complete thought. A phrase, like the things we just saw, is not a complete thought. So a clause contains a subject and verb at least, and then it can have modifiers of them. Here's an example. We will leave for the park in 5 minutes. Or, I like dogs. Or, the big brown dog barked at me. Or, scared silly, I ran quickly to the new chain link fence. And then, thank goodness, climbed it before the dog got there. or we hold these truths to be self-evident, that all men are created equal, that they are endowed by their Creator with certain unalienable rights, that among these are life, liberty, and the pursuit of happiness. Okay, now a simple sentence just contains a subject and verb, no modifiers. It's a clause, but it's just a simple one. Like, he went, she saw, I conquered. Just have subject and verb. All right, having reviewed that, let's look at this proof one is asked to do in that geometry book. So what we want to do is find the skeleton of the sentence, the main clause, and the chief part of it, and we want to try to pick out the prepositional phrases in here. So the first one is from any point. From is your preposition, and point is the object of the preposition. Next one is in the base. In is your preposition, base is the object of it. Then of an isosceles triangle. Of is the preposition, triangle is the object of it. Next one is to the equal sides. Next one is down there at the bottom, to the sum. Last one is at the end, of the equal sides. So all these things in blue are prepositional phrases. Now we have one subordinate clause in here, as it's called, whose perimeter is equal. Okay? That's not a prepositional phrase, it's a subordinate clause. Notice we have a subject in it, the perimeter, and a verb, is. Now if we get rid of the prepositions, prepositional phrases in the subordinate clause, and we see what's left, it says if parallels are drawn, a parallelogram is formed. This right here. If parallels are drawn, a parallelogram is formed. But what else is going on there? What's the context for that to happen? So let's look at this first part. If from any point in the base of an isosceles triangle, parallels to the equal sides are drawn. Okay, so the point is in a base, and the base is the base of an isosceles triangle. So we can't have the point without the triangle. We can't have the base without the triangle. The base is part of the triangle. So the triangle is the thing we need to do first. We need an isosceles triangle if we're going to do any of this at all. So we got this isosceles triangle ABC, where AC and BC are the two equal sides, and AB is the base. That's the base of the isosceles triangle. So we got that part. And now we've got a point in the base. D is the point in the base of the triangle. And then once we have that, what does it say? Parallels are drawn to the equal sides. Notice parallels plural. So DF was drawn. That's one parallel. DF is parallel to AC. We have the little arrows to mark it there. But we need parallels, plural. So DF is parallel to AC, but what about to BC? We have to draw another one. So FD is parallel to BC. So now we have two parallels drawn. Parallels plural, equal sides plural. So DE parallel to AC and DF parallel to BC. And we got them marked with the green and orange arrows. Okay, now we have all that thought out and put in our diagram. So if that happens, do we get a parallelogram formed whose perimeter is equal to the sum of the equal sides? So let's figure out what that means. So first of all, do we have a parallelogram? It says, if something, then a parallelogram is formed. Well, clearly, yeah. By definition, it's a parallelogram because opposite sides are parallel. Now, is the perimeter of it equal to the sum of the equal sides. And the equal sides are AC and BC. And the sum of those is AC plus AB. Or excuse me, AC plus BC. So we need to see if the perimeter is AC plus BC. Okay, hopefully that's clear. If not, just stop it and think about it. And now I'm not going to go through the proof. I just wanted to analyze this so we know what to do. Because we've got our diagram drawn, and now we need to see if AC, well, if the perimeter is equal to AC plus BC. Once we got that, once we prove it, we're done. But that's the thing we got to prove. Okay, let's look at diagramming it. If we go back to the skeleton of the sentence and look at the first part of it, the main clause is a parallelogram is formed. Okay, if is actually a subordinating conjunction. And I'm not going into a lot of detail about this here, of course. You can look at a grammar book to understand this more. But if is a subordinating conjunction. So the if part of the sentence is a subordinate clause. So our main part is a parallelogram is formed. And we got that there. Okay? I've got that diagrammed. And then I need to hang on it the subordinate clause. You know, subordinate means like below or dependent upon the main clause. So we diagram it like this. We put it down below the main clause. Now let's add in a little more of the sentence to this. Okay, still, I've got the subordinate clause whose perimeter is equal, and we still haven't put in the prepositions yet. We'll do that in the next slide. But whose perimeter is equal, I hang down there like that, because we're talking about the parallelogram. Whose perimeter is it? It's the parallelogram's perimeter. So it's the perimeter belonging to the parallelogram. So we're telling something about the parallelogram. Now when we hang on some prepositions, we get this. So notice the if part, I don't have all of that clause there. I'm going to have it on the next slide. I couldn't fit it on this one and have it still be big enough to see. But notice we've got if parallels are drawn, and so on and so forth, comma, a parallelogram is formed, this at the top, and then whose perimeter is equal to the sum of the equal sides. So I'll read that again. So on the if part, if parallels are drawn, blah, 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 comma, starting at the top and then going to the part below parallelogram, we have a parallelogram is formed whose perimeter is equal to the sum of the equal sides. And here's the subordinate clause after if diagrammed. So that's what it would look like. It helps you understand the sentence and what depends on what and what's describing what. Okay, thanks for watching. I hope this helped. Like I say, if you learn your grammar, it's going to help you be able to do word problems and proofs a lot better. Of course, you know, it's not the final answer. It's only one key to doing these, but it is an important key. I hope you have a good day and enjoyed the video. Thank you very much.